No forest tool works quite like this one. The Blue Diamond Severe Duty Brush Cutter is built for power and control, slicing through thick vegetation like it's nothing. Swift Fox Industries shows how it conquers dense brush and small trees in a pasture cleanup. Every rotation of the blade tears through stubborn wood, sending chips flying in seconds. The opening task involves lowering the skid steer's front attachment onto the overgrown patch. As the operator engages the hydraulic motor, the cutter head begins shredding bushes and willows into mulch. The spinning mass of steel handles twisted stems and tangled roots without slowing down. You can tell it's designed for serious clearing jobs, not light trimming. Next, the operator moves methodically across the area, overlapping each pass for full coverage. The thick debris turns into a clean, even layer of mulch. Seeing it slice through trunks that thick makes you rethink what compact machines can do. Some might say it's overkill for small bushes, until they see the result. The once crowded pasture turns open and usable again. That's one way to turn hours of manual work into minutes of hydraulic power. The cutter barely flinches after all that punishment. Its reinforced deck and dual flywheel design prove why it's called severe duty. Wouldn't mind having one of these for weekend yard work, if only it fit through the gate. Power takes a different form in the forest, shown through the steady rhythm of the Ponce Buffalo forwarder at work. Hydraulic cranes lift cut logs and rotate them into perfect alignment on the carrier bed. Each motion looks like strength turned into flow, all while the operator keeps calm focus inside the cabin. You'd expect rough moves here, but it's surprisingly smooth. The articulated frame allows stable traction through mud and slopes, keeping progress nonstop. Once loaded, the vehicle carries tons of timber to roadside stacks before looping back for more. Even the coordination between crane and wheels feels almost instinctive. Log homes begin with timber that must be nearly perfect, straight, dry, and strong. Each log passes electronic scanning before the Norwood OS27 lathe shapes it to the finished profile. Grooves for wiring and window slots are milled with precision tools. The final touch adds antiseptic protection. Guess that smell of fresh pine lingers for days. Speed and control define the experience of cutting solid timber on the Frontier OS27. This portable sawmill from Norwood handles logs up to 69 centimeters in diameter and 3.5 meters long, turning them into precise boards and beams. The process opens with the operator securing the log onto the bed and adjusting the clamping system. As the blade moves smoothly through the wood, each pass delivers consistent thickness. Even small adjustments make a big difference in board quality. Sawdust flies as the engine powers the band through dense grain. You'd be surprised how stable the frame stays even under full load. Optional extensions allow longer cuts for construction use. The OS27's balance of portability and strength makes it ideal for remote work sites. One wrong move, and you're slicing an expensive mistake. No pressure. Efficiency really shows when one person runs the whole setup solo. The smell of fresh-cut timber mixes with the calm rhythm of machinery as each panel finds its place. This is how a timber frame house is born in the precision-driven halls of Schenck, through a balance of design, craftsmanship, and clever logistics. Every stage in this prefabrication line reflects both experience and innovation, showing how modern wood construction blends speed with structural integrity. The operation opens with digital groundwork. Using CAD software, the team turns architectural concepts into precise blueprints. Each wall, joint, and ceiling element is modeled in detail, ensuring that every cut later matches perfectly on site. Adjustments happen virtually long before any wood touches a saw. It's wild how much real construction starts in front of a computer nowadays. Next comes material transport, a disciplined flow that keeps the process efficient. Timber panels, insulation layers, and connectors move seamlessly between stations. Workers and machines share space in sync, reducing downtime. The result is an impressive choreography of movement and purpose. You start to see how efficiency becomes an art when people and machines move as one. Cutting marks a turning point. Automated saws slice through massive wood sections guided by CAD data. Each piece receives labeled markings for its exact position in the final structure. You can almost imagine how those clean cuts will later align like puzzle pieces. The accuracy ensures minimal waste, a win both for cost and sustainability. Prefabrication then branches into three main paths: inner walls, outer walls, and ceiling sections. The inner walls integrate electrical conduits and insulation before being sealed. The outer walls receive weatherproof layers and structural reinforcements. Ceiling panels come last, built to withstand both weight and acoustic stress. Kind of funny how ceilings, often overlooked, demand such precise engineering. When all elements are complete, everything heads to the construction site. Cranes lift prefabricated panels into place like giant blocks, locking together with remarkable speed. Within hours, a structure takes full shape, sturdy, airtight, and ready for finishing. Seeing an entire house assembled this smoothly almost feels like watching magic done by engineers. This approach to timber construction doesn't just save time. It ensures higher quality, safer working conditions, and energy-efficient results. Schenk's system proves that modern housing can still carry the soul of craftsmanship, just reimagined for today's world. It's that blend of efficiency and authenticity that makes this method genuinely inspiring. A thick slab of hardwood turns into a finished door with the help of one impressive piece of CNC engineering. This isn't just woodworking, it's industrial precision on a creative scale. The CR Onsra G-Series 4-axis machine takes control of the entire process, blending mechanical power with digital accuracy that would make any craftsman proud. Every cut demonstrates how technology can multiply human skill without replacing it. Production opens with digital modeling. Each door profile is drawn in CAD software, then converted into toolpaths for the CNC router. Once the program is loaded, the blank wooden panel is fixed onto the machine bed, locked tightly for perfect stability. Kind of funny how the setup feels longer than the cutting itself. Even a small misalignment at this stage would show in the final fit, emphasizing the importance of preparation. Next comes the machining stage. The aggregate ring under the spindle lets the machine grab specialized attachments from the automatic tool holder. These aggregates turn a standard 3-axis router into a 4-axis powerhouse, allowing angled cuts, groove carving, and deep mortises in one continuous run. Every rotation counts. Nothing's left to guesswork. The profile cutting then takes center stage. The dust hood is lifted, revealing the bit-shaping door edges in one smooth motion. Chips fly, corners emerge, and within minutes, the solid wood starts to look unmistakably like a door. The speed here would surprise anyone used to hand tools. Even the smallest decorative detail is carved with the same reliability as structural cuts. After shaping, the machine switches tools automatically to drill hinge and lock set holes. No repositioning, no manual marking, just pure programmed consistency. Finally, the sanded and cleaned panel moves out, perfectly milled and ready for coating or staining. What leaves the CNC isn't merely a door, it's proof that modern woodworking can stay loyal to solid wood while embracing advanced technology. This process keeps craftsmanship alive, just with new tools in the mix. The combination of speed, accuracy, and repeatability ensures every door meets exacting standards. A whole home built faster than a weekend, yet built to last for decades. That's the idea behind the Renggli Vision R4 modular house, where 4 room-sized units come together to form a complete, energy-efficient living space. Each module is crafted to near-millimeter fit, so when they join, the seams nearly disappear. This level of prefabrication doesn't just speed things up, it redefines how modern housing feels. Somehow, it makes the line between factory and home blur in the best possible way. The operation opens inside Rengli's production hall, where every wall and ceiling module takes shape under controlled conditions. The wooden frames are assembled with integrated insulation and hidden conduits for power and ventilation. Each panel is pressed, sealed, and inspected before moving forward. The air inside the factory feels more like precision engineering than typical construction work. You'd never guess that a full family home can be born here in less time than a single renovation elsewhere. The quiet confidence in each worker's motion says more about expertise than any slogan could. Then comes the interior fitting. Floors are laid, electrical systems are installed, and fixtures are mounted while modules still rest inside the workshop. Finishing details, tiles, cabinets, lighting, are added as if building inside a real home. Nothing is rushed. Every movement follows a tight sequence designed to minimize on-site labor later. Once the modules are complete, the transport team takes over. Trucks carry the 4 prefabricated units across Switzerland to Rothrist. Each one travels fully enclosed, already containing most interior finishes. Watching those massive wooden boxes glide along the highway must turn heads, like moving entire rooms instead of furniture. The logistics are timed so precisely that the foundation is waiting, leveled, and ready the moment the convoy arrives. It's a reminder that modern construction depends as much on timing as on tools. Assembly on site is a spectacle of coordination. Cranes lift each module into place within hours, guided by engineers ensuring perfect alignment. Walls lock into their neighbors, creating airtight joints that maintain thermal performance. The structure stands fully enclosed before sunset. Hard to believe that 4 hours separate an empty slab from a livable home. Even the neighbors might think they missed a week somehow. Few projects prove so clearly that innovation isn't about doing more, it's about doing smarter. The finishing phase ties everything together. Connections for water, heating, and electricity link through pre-fitted channels. Once tested, the house becomes fully operational in less than a day. That means by the next morning, lights turn on, doors open smoothly, and the air inside already feels like home. This method isn't just about speed. Prefabrication ensures consistent quality, safer working conditions, and less environmental waste. It also enables tighter energy performance. Each R4 module comes with efficient insulation and controlled ventilation, cutting long-term costs. The result: a modern dwelling built under factory accuracy, yet warm with human intent. It's the kind of innovation that turns construction into design thinking, not just building. A single wall that insulates, supports, and lasts for decades. This is what value therm panels deliver. Built under strict factory control, they combine the principles of SIPs and timber frame technology into one hybrid system. The process is not just about speed, it's about achieving consistent quality that outperforms traditional construction. Each step feels engineered for durability rather than mere assembly. Production opens with computer-aided design and CAM manufacturing, turning digital plans into precisely cut timber components. The optimizing saw trims materials with near zero waste before the framing station brings the skeletal form together. Both sides are sealed with sheathing, nailed automatically by a computer-controlled bridge that ensures uniform fastening. Even small movements on that bridge reflect years of refinement. Panels are flipped using butterfly tables, smooth and efficient, to prepare for insulation. At the next stage, panels are stacked inside the value therm press, where recycled vegetable oil insulation is injected under 100 bar pressure. That's some serious green tech meeting industrial muscle. Once the insulation cures, vapor control layers and battens are fitted, followed by the breather membrane. The precision here keeps every future home airtight and energy stable. Factory-fitted windows and doors complete the modules before inspection. Imagine saving weeks of site labor by finishing all this indoors. Certification by the British Board of Agreement guarantees a 60-year lifespan. Sustainability and endurance finally share the same frame. Wood strips converge with exacting intent to form structural panels that will hold entire buildings. The X-Press system at Lapia, Finland delivers this engineering feat by pressing cross-laminated timber elements, CLT, with unmatched efficiency. Each step combines automation and thoughtful design, producing panels capable of supporting walls, floors, and ceilings. This isn't just pressing wood, it's structuring reliability. The operation kicks off with panel preparation. Loose strips are sorted by thickness and quality before being laid into longitudinal and cross layers. Prefabricated cross layers can also be stacked with fresh longitudinal strips to achieve the recommended pressing configuration. The stacks resemble giant sandwiches, but each slice has a purpose. Next, the X-Press flat press clamps the layers together. Hydraulic pressure flattens and bonds the laminates evenly across the panel. The system accommodates a range of CLT types, BSP, KLH, and cross-plan, ensuring uniformity regardless of the layer combination. Observing this, the precision behind automated pressing becomes evident. Even minor deviations could compromise structural integrity. Once pressed, panels remain under pressure until glue cures, guaranteeing stability. Then, they are carefully removed and moved for further processing, ready to be cut, drilled, or fitted with mechanical connections on site. Workers manage these transitions smoothly, maintaining workflow continuity. The level of control allows consistent results for panels of varying thicknesses and lengths. X-Press panels optimize material use while meeting stringent strength standards. By combining pre-assembled layers with fresh laminates, production achieves both speed and quality without sacrificing safety. Factory control also reduces waste, allowing eco-conscious construction practices. Lapia's system proves that modern timber engineering can harmonize efficiency, precision, and structural confidence. Even when dealing with massive wall sections, the process remains methodical. Each panel carries a promise: dependable performance, energy efficiency, and a foundation for durable buildings. This is how cross-laminated timber rises from individual strips to a cornerstone of contemporary construction. How can a full wooden house be built in just 1 week without compromising stability? Systember technology provides the answer, turning solid wood into a reliable structure with remarkable speed. Every step on site follows a precise order, making sure efficiency and structural integrity go hand in hand. Preparation begins as tailor-cut wood arrives with all necessary materials. Vertical construction follows. Systember beams are placed upright, connected using hidden anchors that secure them to the floor, while spacers maintain room for natural wood movement. The precision here reduces future settling problems. As walls, floors, and roofs take form, Sherpa connectors attach laminated beams to the structure. Panels can either be connected directly on site or prefabricated in the workshop for faster assembly. Smart planning like this highlights how modern wood systems maximize time and labor. By day 4, the main frame is solid, airtight, and ready for finishing. Windows are screwed directly into timber beams, creating stable and energy-efficient openings. Roof installation, insulation, and exterior finishing follow immediately. Seeing all steps align like this underscores the value of prefabrication. Sistember's method balances rapid assembly with long-term stability. Workers navigate the sequence with consistent rhythm, avoiding errors that could compromise structural integrity. Even modest dwellings benefit from these techniques, improving quality across housing projects. This approach shows that engineering insight can enhance traditional timber construction. Each completed home tells a story of modern wood craftsmanship, where every anchored beam and spacer plays a role in creating a durable, comfortable space. Massive timber panels stack up like puzzle pieces, forming the backbone of a floor that will carry rooms above. In XLAM assembly, panels arrive prefabricated, each layer engineered for structural strength. Workers align them carefully, locking panels side by side, creating a continuous load-bearing surface. Hidden fasteners secure connections, keeping the joints tight while allowing natural wood movement. The next step involves bracing and anchoring. Each panel is supported temporarily while connections are finalized. Screws and mechanical connectors ensure the panels remain stable during subsequent construction stages. Finally, panels are inspected for uniformity and stability. Only when everything meets standards does the crew move on to walls or roof installation. Using prefabricated panels saves time on-site while maintaining high structural quality. This system proves that modern timber engineering can combine speed, strength, and environmental responsibility. What makes these timber beams stand perfectly upright without a single wobble? In the Mosersweed project, modern timber engineering meets traditional construction in Appenzell, Switzerland. Each beam, carefully prepared, is ready for assembly on-site, combining efficiency with structural integrity. Observing the coordination, the harmony between planning and execution is impressive. Assembly starts with positioning the vertical beams. Each beam is anchored to the floor using hidden fasteners, while spacers maintain consistent gaps to allow natural wood movement. Hidden fasteners secure the beams firmly, ensuring stability while accommodating the wood's natural expansion and contraction. Next, horizontal connections are made. Laminated beams link walls, floors, and roof elements together with mechanical connectors. Panels can either be connected on-site or prefabricated in the workshop, offering flexibility in construction. Workers adjust alignment to guarantee precise joint formation, crucial for long-term structural performance. Windows are then installed directly into the Sistember beams, enabling rapid integration with the walls. Roofing, insulation, and exterior finishing can follow immediately after Sistember construction is placed, speeding up overall building completion. The sequence keeps workflow smooth, maintaining high quality without sacrificing speed. Even when dealing with complex multi-story sections, the methodical approach ensures consistent results. By combining pre-cut elements, hidden anchors, and standardized connections, this system exemplifies how modern timber construction balances speed, precision, and environmental responsibility. Bold coordination, intelligent design, and systematic execution make every beam count. The Mosersweed project proves that traditional materials can thrive under modern engineering principles. Each board, measured to the millimeter, contributes to a single bespoke furniture piece crafted in the facility. At the MOBALPA facility, the automated lot size 1 production system orchestrates each step with industrial intelligence. You notice the precision in every stack, like each panel knows exactly where it belongs. Every adjustment is logged and analyzed to prevent recurring errors. Production opens with careful work preparation. Orders are analyzed and planned, defining the sequence for individual pieces. Each material batch is supplied just in time, ensuring no excess inventory clogs the workflow. The planning software predicts bottlenecks before they occur, optimizing efficiency. It's impressive how planning dictates the flow without slowing the machinery. Next, commissioning and stacking bring order to the production line. Boards are sorted and grouped according to their specifications. This pre-sorting allows the BIMA cutting center to process materials efficiently, ensuring that each panel is correctly positioned for the next step. The system can switch between different wood types without delay. Watching this coordination makes you realize how much logic is embedded in seemingly simple stacks. Data from previous runs guides every operation to reduce waste. The cutting stage is handled by the BIMA cutting center. Boards are cut precisely according to the pre-programmed dimensions, achieving flexibility for lot size 1 production. The cutting path is dynamically adjusted to maximize material use. The system is designed for individuality, producing unique pieces without compromise. Edge processing follows immediately, integrating drilling and dowel insertion in a continuous automated run. Operators can track progress in real time via the integrated dashboard. The seamless transition between cutting and edge finishing saves both time and potential errors. Even unexpected changes in dimensions are accommodated without stopping production. Material flows from one station to the next with minimal human intervention. The system's automation ensures that each board arrives exactly where it should, ready for further machining or assembly. Operators maintain oversight, but the machine carries most of the load, a true testament to engineering foresight. Energy-efficient motors reduce overall power consumption. Inspection and quality control are embedded at every stage. Each board is verified for dimension, alignment, and readiness before moving forward. Any deviation triggers an immediate correction, maintaining high standards throughout the line. It's rare to see such consistency across individually customized furniture pieces. Finally, completed boards are stacked and prepared for assembly or shipping. The integration of cutting, drilling, and edge processing ensures that each component fits perfectly in its intended place. Even in a production hall buzzing with activity, the precision of automated handling is remarkable. The modular system allows rapid reconfiguration for different orders. Throughout, the system embraces flexibility and individuality. Orders of a single piece, unique in size or specification, move along the line without slowing the overall production rhythm. This shows how modern automation can adapt to bespoke manufacturing demands. Staff receive automated notifications for maintenance needs, reducing downtime. The combination of pre-planning, automated cutting, and integrated edge processing proves that mass customization is achievable without sacrificing quality or efficiency. MOBALPA's automated lot size 1 production demonstrates that technology can maintain human-level care and creativity while delivering unmatched consistency. Each step, work preparation, commissioning, cutting, edge processing, and final inspection, reflects a carefully balanced dance between human oversight and machine intelligence. Even a casual visitor can appreciate the elegance in the organization, from pre-sorting stacks to the flawless execution of edge finishing. Safety protocols are automatically enforced without interrupting production. By integrating innovative production technology across the entire facility, the workflow achieves efficiency, flexibility, and quality simultaneously. The way each board moves through the system makes it obvious that customization doesn't mean compromise. For furniture manufacturers, this approach offers both scalability and individuality, proving that industrial automation and tailored production can coexist seamlessly. The workflow data can inform future design improvements for continuous innovation. Stepping through Boise Cascade's Kettle Falls plywood mill, the scale of precision and planning immediately captures attention. Each log is carefully selected by species and diameter, weighed, and sorted to guarantee consistent production. The team's experience is evident, with employees guiding automated systems while monitoring every step. Logs are first debarked and conveyed to large cutoff saws, where they are cut into blocks about 103 inches long. These blocks are conditioned with hot water for 8 to 12 hours, softening fibers to produce higher quality veneer during peeling. The patience invested in conditioning affects the final panel quality more than most realize. At the lathe, blocks rotate against a knife, producing continuous veneer ribbons. Unusable core is separated for other products, ensuring minimal waste. Veneer sheets are sorted by size, moisture, and grade. Full sheets are reserved for face and back panels, while random and fishtail pieces are trimmed for inner core layers. Each sheet is dried to a specific moisture level, reducing shrinkage and improving glue adhesion. Monitoring moisture content so precisely ensures consistent panel performance. Assembly involves layering veneer with foam glue, forming a crosswise core with random pieces. Panels undergo pre-press squeezing, followed by high-pressure pressing at 190 psi and 300 degrees for several minutes. Finished panels are trimmed, stamped with APA-grade information, and visually inspected. Defective panels are removed, while approved panels are stacked and prepared for transport. The integration of experience, technology, and quality control reflects the sophistication required in modern plywood production.